Hi everyone, I am Naveen Kumar and today we are going to see the light and what are the laws we are having in the light and about a Snell's law. Okay, so before getting into that, we are going to see uh, introduction of light. So these are the agendas: introduction of light, so reflection and refraction. So the Snell's law, the reflection and reflection are the two laws we are having in our path of the light ray, and totally internal reflection and optical fiber. So in case we are using a medium as a optical fiber, there we can see these conditions and the dispersion. Okay, so now, so in light, so normally what is a light? So light which travels in a straight line. I think everyone know the light which travel in a straight line, and the light will get reflect in a smooth surface, or it's based on the surface, what kind of surface we are having. So in this, first we will see what is by reflection and what is by refraction. So after this, so what are the types of refraction we are having in it? First, what is reflection? So normally the reflection is nothing but the light, especially we call it as the incident rays or incident light waves. Okay, so the light which travel in a free space, or we call it as a vacuum space, and if we are having a smooth surface as a mirror, here we can take an example of mirror. When the light incident on the smooth mirror surface, there we can see the light will get reflected. Okay, so the light reflection is based on the surface. So here the reflector light leaves normally. So here the reflector angle is equal to incident light. So that's it's called theta I is equal to theta R. So the reflected light leaves the surface at the same angle it was incident on the surface. So that's why it's called as a theta I equal to theta R. So how it's possible? So we can see here. So this is the incident ray. When it was incident on a flat surface or smooth surface, it is getting reflected from the surface. So here the angle between the origin and the incident ray is theta I, and the angle between the reflected wave and the origin is a theta R. So here if the surface is smooth, both the angle will be equal. This is the condition of reflection. If the condition of the reflection, if the surface is smooth in it. So that's the important point on here. And what happens if the surface is rough, or it's not a flat surface? What will happen in that case? So here, if the smooth surface means the incident rays will be equal to the angle of incident rays will be equal to the reflected ray. So but in case of rough surface, the incident rays will reflected in all the direction. For example, we can take for smooth surface we can take an example as a mirror, and for rough surface we can take an example of water medium. Okay, so in the water surface, the light will incident light will get reflected, at the same time the refraction will be also occur. So the light, what is the refraction means? We will see it in the next slide. So refraction is nothing but the light which pass through the water medium. So that's called refraction. Okay, so now, so here in case of rough surface, the light of incident, okay, so here it's shown as a different color. So you already seen in the prism. Okay, so the light will have a different surface of colors, but it's based on the surface of reflection, so the color will change. So that's what they are trying to say it here. And next one is the refraction. So what is the refraction? So the light travels in a straight line except when it is reflected, or when it moves from one medium to another medium. So that's what I said, example of a water medium. So normally in a water medium, so the light will get reflected, and at the same time it will get refracted. So it's passed through the water. Okay, so that's a water medium. It's a transparent, so the light will get bend or change of direction. Light rays, it's based on the water medium. So even in the water medium we are having a different quality of water. So if it's a pure water, there will be a more reflection in it. If it's a contaminated or dull color water, there the medium will change and the refraction and reflected angle will be changed. So that's called refraction. So and here, so how to calculate the refraction of a material? Okay, index refractor. So n is called as an index refractor, and here the speed of the light in vacuum. So that's a c is nothing but a 3 into 10 to the power 8 meter per second. So here the formula to find the index of refraction of material is n equal to c by v. So here we c is a constant value. So that's the maximum of light travel speed. So 3 into 10 to the power 8. So here v. So v is nothing but here it's the speed of the light in the material. The speed of the light will vary. It's based on the what medium we are using here. And at the same time, the speed of the wavelength of light changes when it passes through one medium, but the frequency of the light won't change. So that we can calculate from this v equal to c by n. So here we know the speed of the light, and at the same time we know the n value. From that we can calculate the wavelength. So that's so how to calculate the wavelength means is the lambda n equal to lambda by n. From that we can calculate it. So here some example to calculate the speed of the light in diamond. So here I already told what is meant by n means it's a refractive index. So n is 2.42. Okay. So here the water refractive index is 1.33 and glass refractive index is n is 1.5. It's approximately 1.5, and in the vacuum, so air space, we can have a n equal to 1. So these are the constant values. So from this we want to calculate the speed of the light in diamond. So v is equal to c by n. So here we know the value of c, and they already gave the refractive index of diamond n equal to 2.42. By substituting the c by n, we can find the speed of the light in diamond. So that's one example. We can calculate it from the reflection formula. So now reflections Snell's law. So here when the refractive index is greater than or equal to 1, what will happen? So when it is greater to equal to 1 means n water is 1.33. So that's a constant value. In that case, the positive refraction, that means there will be some change in angle, but it will not equal to the incident ray. So that's a positive. But in case of if the refractive index is less than 1, then the negative refraction will occur. There the incident wave is perpendicular to the refractive wave. So that's the condition when the refractive index is less than 1. Okay, and next one is the Snell's law. So when light moves from one medium into another, some reflected at the boundary and some is transmitted. So that's an example what I said, the water medium. So some of the waves will get reflected and some of them will get refracted. Okay, so in that case, when the light incident on the water medium, so some of the wave will reflect in the air space and some of them will pass through the water medium. So that's called, we call it as a refractor medium. So with the help of a Snell's law, we can calculate what will be the refractive index. Suppose if the light wave travel from air to water means, you can see the condition will be in the first image. And suppose if the light will travel or incident rays travel in a water medium and then it will enter into air medium means there the refraction ray and the angle will be differ. So this we can calculate with the help of a Snell's law. So the Snell's law equation is NA sine theta A equal to NB sine of theta B. So with the help of this Snell's law we can calculate what is the refraction in the different mediums. So these are the some of the constant light passing from air into water and water into air. These we can calculate with the help of a Snell's law. So now what have we seen? So what is meant by light? The light which travels in the air space, the refractive will be, index will be different, and when it enter the different medium, here I said example of water, and we seen one example of a diamond here. So when the light pass through the water, the refractive index will be differ, and when it and the speed also differ and the wavelength also differ. But when it enter into the, if suppose the light will travel in a diamond, there the refractive index is totally different. Okay, so with the help of a Snell's law we can calculate what are the values or incident, reflection, everything we can calculate from the Snell's law. I hope everyone understands it. Thank you. Thanks for your time. Thank you.